Hi, I'm glad to have this opportunity to present our research outcome from the work package 4.6 energy utilization. This work has been jointly done by Mandela Mining Precinct, Center of New Energy Systems from University of Pretoria, CSIR, and Enterprises University of Pretoria. My name is Xianming Ye, an associate professor from Center of New Energy Systems, University of Pretoria.
To start with, I'd like to introduce the methodology POET energy efficiency framework that we utilized to guide our research work. The word POET refers to performance, operation, equipment, and technology. So this energy efficiency framework is very useful and powerful. Firstly, if we look at the forward loop from technology to performance, it's actually the process we do energy modeling because we gathering information by energy audit, and it can also guide us the process of energy auditing. And then with all these details of energy audit, we can come up with the system baseline, and based on the system baseline, it can help us to set up targets, install necessary metering devices for performance verification purpose. And then when we look at the backwards loop from performance to technology, this is the process where we do energy optimization, where we actually design and planning about which technology, which equipment, and what is the optimal strategy of operation in the system. And then the entire loop can actually advise about the financial and technical viability of this work. So underneath the guidance of POET, we actually conducted three parts of work. Firstly, we conducted a literature review. Based on the review outcomes, we designed the holistic energy efficiency guideline for the mining industry. Lastly, in order to share the knowledge that we studied, we actually organized industrial workshops in the process. Lastly, in this presentation, we also like to advise the way forward after this study. So our review covers three major parts. The first part is the alternative energy resources, which includes solar PV, concentrate solar power, solar thermal for process heat, biomass and biogas, and wind power. All the necessary technical details are given in our final report. The second major category is the energy storage systems, which include mechanical, electrostatic, and electromagnetic, electrochemical, chemical, thermal energy storage systems, etc. There's lots of technical details involved, and then we actually have very interesting discussions with our stakeholders during the research process. The next essential category is the energy utilization optimization via EEDSM approach, which refers to energy efficiency and demand side management. On my left-hand side, so this shows the categories and the strategy for energy efficiency for EEDSM. And the figure on my right-hand side, which summarize the top 10 most energy-intensive process in the mining sector. So all of the EDSM strategies has been proposed to these energy systems. The details can be found in our final report. So based on the review, we come up with an energy efficiency guideline. This guideline actually covers four major components: energy efficiency specifications, energy optimization and modeling, national energy efficiency policy framework, and also green fund opportunities. So to enable energy optimization, we need energy models. And there are two major categories that we set up energy models: the data-driven energy models and also first principle models. So this figure summarize lots of the data-driven approach to help us to developing data-driven energy models. And then when we have multiple energy models, we also advise based on the model selection criterion because you would like the model to be true, useful, and simple. So lastly, there's a guideline on the energy modeling process because finally we want the model prediction to be closer to our observed output. So that's the fundamental principle for data-driven energy models. The second energy modeling category is the first principle energy models. And then here is the energy modeling procedure. More detailed explanations are available in our final report. So when we have necessary energy models, we can set up energy optimization. So then it helps us to make decision about how we incorporating alternative energy resources, which energy storage system that we can apply, and which energy efficiency and demand side management strategy that you would like to apply to improve your plant-wide energy efficiency. So energy optimization covers the following three major components: the objective function, the decision variable, and also the constraints. Usually to formulate your objective function, you need to understand your preferred financial or technical or a combination of these indicators such that you can have a multi-objective energy optimization. And then the outcome of this energy optimization are actually those decision variables in terms of system component sizing, which refers to technology and equipment in the POET framework. Your power flow management, which is a best operation strategy, etc. And then in most of the case, the energy optimization formulations are subject to constraints, such as boundary limit and operational constraints. So as I mentioned, this optimization must be formulated based on the support of energy models, such as your energy price model, weather conditions, and also the technical renewable energy system models, etc. So here is a case study of an optimal battery sizing and operation, which propose an expansion of the battery based on existing setup of solar PV. And then this curve gives the charging and discharging strategy, and this peak also advises the size of your solar PV. And then based on your load condition, the tariff, and then the system can advise you how to optimally operate your PV battery and the grid connection. From the energy policy point of view, we also advised the details of carbon tax, section 12I, 12L, 12B, energy efficiency policies, and also the renewable energy independent power producer program. And more details are given in our final report. So there's also green fund opportunities from the UK. We have discussed, we collaborate, and we try to apply it for this fund. So we can continue try so and then to obtain more green fund. So to share our research outcomes, we organized 2 industry workshops. So in both workshops, we invited the necessary researchers, stakeholders from the mining sectors, and then we had lots of interesting and essential technical discussions in terms of the plant-wide energy efficiency. We received lots of positive feedback and also valuable comments to further improve our work. So in terms of the way forward, we would like to highlight the following focusing areas. We need demonstration and implementation of the renewable power generation energy storage systems with the green policy and the green fund. We also need new power business models. As you can see, there is a clear trend of energy efficiency transition from the fossil fuel-based energy generation system to renewable-based energy generation system. And then the key successful factor is the industry academic partner. So where we believe the academic need experts plus postgraduate student training, and then we can generate knowledge transfer, human capital development, which can help to address the challenges of energy efficiency. And then we actually proposed to build a demonstration of optimal sizing and operation of solar power generation system, which is shown in this graph. And then we hope to receive your continuous support for this proposal. Thanks, everybody. That's the end of my presentation.